I would like to move beneath the water column and beneath the water bodies that Alex just showed us, down to the floor of the North Atlantic, which is a very busy space that's crisscrossed with telecommunications cables, shipwrecks, and amazing geology. It's a space that has hosted arguably some of the most important marine scientific discoveries, and during the 1950s, it was a hotspot for Western research. And at that time, there was a growing demand for knowledge of the ocean floor, with the rising number of commercial crossings, intrigue whipped up since the sinking of the Titanic, and increasing military interest. The early stages of the Cold War were generating tension and competition between states to explore their submarine territory, to gather oceanographic data, and to produce more accurate seafloor maps to aid their submarine operations. At the same time, international collaboration was blooming through the 1950s and 60s, with the International Geophysical Year happening from 1957 to 58, and the inauguration of the Intergovernmental Oceanographic Commission, among other initiatives. So oceanographers and marine scientists were carrying out their work in the context of a pretty shaky balance between a global spirit of discovery and state-backed undertakings. And at this point, the North Atlantic seafloor had already been mapped, first with data collected by the HMS Challenger expedition in the 1870s using fathoming lines, which were these long cords marked with flags indicating depth that were thrown into the ocean. Sonar technology, developed during the First World War, was later used to determine the depth of the seabed and create early contour maps. And it's not that these maps were really inaccurate, they just weren't all that precise, and the data points were very sparse. And Vicky, I think, is going to be explaining a little more about seabed mapping methods. So in their hunt for data, the US military, along with Bell Labs, who were interested in the terrain of the seafloor for laying communications cables for both commercial and military use, funded the then named Lamont Geological Observatory in New York to collect new depth readings across the Atlantic. And this image shows some of the transects made by their research vessels from 1946 to 1952. And it gives an idea of the kind of data coverage that was available to make a map of the entire North Atlantic seafloor. So the process of making the map was long and arduous, and it required huge amounts of geological and geophysical expertise, powers of spatial imagination, and pure creativity. So after first determining the positions of the transects, all of the depth measurements along those transects could be plotted as profiles, showing the terrain of the seafloor at an exaggerated vertical scale of 40:1. And then the features shown in those profiles were sketched and shaded to show relief. And finally, the gaps between those sketches could be filled by extrapolation and interpolation to produce a complete map. And most of this work was done by hand, and mostly by Marie Tharp, who was a research assistant at the observatory. She worked under Bruce Heezen, who led the project, and they worked together closely for many years, although their relationship was often strained by disagreements over interpretations. And Tharp received very different treatment from the institution and from her colleagues. For example, as a woman, she was not permitted to join the ocean-going research expeditions, so her work was done entirely on land. And this is the finished map, which was published in 1957 in the Bell Labs Technical Journal, with Tharp uncredited as an author, and then in 1959 with the Geological Society of America, where she was credited. And this map had a significant impact on the understanding of Earth processes, in addition to providing a really unusual perspective on the seafloor to any viewer, regardless of their scientific background. So I'm going to talk about what makes this map so aesthetically particular, about why it was drawn in this way, and its effects on tectonic theory. So three-dimensional and contour maps had already been made of this part of the seabed, but Tharp and Heezen chose this quite unlikely and at that time slightly old-fashioned physiographic form for their map. And the physiographic style has a tradition in cartography emerging from the fields of geomorphology and structural geology, as they were becoming formalized in the early 19th century. And field sketches and block diagrams were used to show the vertical in that time, in order to connect a landscape with its underlying geology. So physiographic diagrams evolved out of these forms of drawing to depict and interpret landforms in a descriptive way, and they were acknowledged to be quite subjective. So the symbols used to denote relief in the map were also created using conventions of physiographic mapping. And rather than applying a certain texture or a color or a discrete numerical scale, relief here is indicated in a qualitative way by symbols from the drawings themselves. The physiographic style might seem like quite an odd choice for this type of map, drawn in response to a military need for data. But the depth readings were classified by the Pentagon, so Tharp and Heezen couldn't present them in place on the map. So their choice of the physiographic form was largely motivated by the political climate, continuing the influence of geopolitics on oceanography that had twisted ever tighter throughout the world wars. Colour is also used in quite a restricted way throughout the map, and in contrast to earlier contour maps of the seabed that displayed different depth horizons in contrasting colours, the only use of colour in this map is as a label or a noun, in the words of Edward Tufts, to distinguish between land and sea. Most of the information in the map is conveyed by shading, added in a hachure style to represent relief. And this approach shows topography in terms of light and shadow, but it's applied to an underwater environment that largely receives no light at all. Physiographic maps were classically used to show the topography of regions or continents from an imagined viewpoint in the sky, in cases where an aerial viewpoint could not be obtained. This is reminiscent of the Dutch and German painting style of Weltlandschaft, meaning world landscape, commonly used to depict imaginary panoramic landscapes from above in the 16th century. The viewpoint of Tharp and Heezen's map is very much imagined. First, the bathymetry it depicts can't be directly viewed by the human eye from any angle, since it's located deep underwater. And second, Tharp constructed the map from data points gathered on board a ship on which she never set foot, adding to the gulf between the reality of the landscape and the map. But despite this gulf, Tharp managed to identify seafloor features with astonishing accuracy. And what's more, she discovered and interpreted new features in a way that changed the course of Earth sciences. The Mid-Atlantic Ridge, a mountain range running through the center of the Atlantic Ocean, had been charted by earlier maps, but Tharp noticed a depression in its center that followed the length of the ridge, which hopefully you can see running through the middle of this image. Tharp interpreted this valley as evidence that new oceanic crust was being formed along the ridge and pushing apart the seafloor on either side. Her interpretations of the valley and of seafloor spreading as proof of continental drift were initially dismissed as, in her own words, girl talk by Heezen, who was instead pursuing the theory that the Earth was expanding. Continental drift was considered a controversial and unproven theory at the time, but Tharp's map and her interpretations provided the crucial piece of evidence needed for the theory to be taken seriously, and it was followed by a cascade of linked discoveries. And as Jeremy Jackson mentioned in his talk on Monday, it still took decades after this for continental drift to really be accepted. So you can imagine how controversial her suggestion was at that time. Apparently, the scientific community were only convinced of the existence of this valley in the ridge at the first International Oceanographic Congress in 1959, where Jacques Cousteau screened an underwater film of the North Atlantic that happened to show that depression. And I couldn't find the footage of that film, but here are some photographs that were published alongside the map in 1959. Although they were of great value for the study of deep sea sediments, they hardly represent the topography of the ridge. There are also photographs of manganese nodules published in this report, but that is another story. The immense value of Tharp and Heezen's map is that it depicts the seafloor in a way that it had never been seen before, by providing a unique spatial and textural perspective of the North Atlantic. This enabled new imaginaries of the seafloor as a landscape, where it almost looks as if you could walk between the mountains. As the first comprehensive map of an ocean basin, it arguably helped to establish a regulatory approach based on the idea of a bounded ocean space, surrounded, shared, and impacted by multiple coastal states. But this would come later, as the map was published at the beginning of a new regime of negotiations over ocean space. This phase of ocean grabbing was partially set into motion by United States claims over the resources of their continental shelf in the 1945 Truman Proclamations, with the aim to expand US jurisdiction over lucrative areas for fishing and oil exploration. This set the precedent for a seawards creep of what was considered state territory. In 1958, the United Nations Convention on the Continental Shelf internationally codified this extension of coastal state rights. And in this context, it's interesting to see the empty and featureless continental shelves as they're depicted in the map. It's easy to view them here as a smooth continuation of the land, as they stand out against the crumpled drama of the deep seafloor. The idiosyncratic qualities of the map reflect its role as a conceptual space of interpretation, opened up from within a complex and in many ways restrictive institutional and geopolitical environment. From individual data points, Murray Tharp perceived an entire landscape on a huge scale and presented it in a way that visually aided further interpretation. And we're lucky enough to have Vicky with us today, who's a seafloor mapping expert and a current member of the Lamont Observatory, which is preparing to celebrate what would have been Murray Tharp's 100th birthday next year. And Vicky knows the story of this map extremely well, so I hope that I've told it all right.